This is our ninth grade physics topic 4 cycle 1 homework video on energy. Um, and this is just following up our intro lab on energy and types of energy. So one thing to note is the unit that we'll be using, the joule, abbreviated capital J, amount of energy equal to the work done by 1 Newton of force over a distance of 1 meter. So that means if we pulled an object with the spring scale reading 1 Newton over the length of 1 meter stick, you'd have done the work equivalent to 1 joule of energy. Now, the fundamental concept here with energy is that energy is not created or destroyed. So any energy gained by a system, and what we mean by a system is if you think about the skateboarder in our lab going back and forth, if we put a box around the whole skateboard ramp and her, either she is walking up the ramp to doing work to gain the energy that she gets when she has gravitational potential energy at the top, or somebody's lifting her up, whether it's a elevator or an outside force to provide that energy. That energy didn't just come from nowhere. So energy is never created or destroyed, just transferred. So that means the total energy of a system remains constant. So we can find the total energy at one point and determine how it was transferred. So the different types of energy we're going to talk about. The first is gravitational potential energy. So it's energy gained by distance from the Earth. Basically, it's the energy, if I lift an object, it's the energy that object could potentially have right before it hit the ground if I let go of it. So it's gained from gravity and the pull of gravity down towards the Earth. As a result, it's the force of gravity, which is mass times acceleration due to gravity, times the distance or height. And we're going to talk about how this really corresponds to work in the vertical direction in just a second. So gravitational energy is one type of energy due to distance from the Earth or height. The second type of energy we're going to talk about in this cycle is kinetic energy, so energy of motion. So energy due to a mass having velocity. And note that velocity is particularly important as the kinetic energy is 1/2 the mass times the velocity squared. So velocity plays a very important point in kinetic energy. We're also going to talk about dissipated energy. In our lab, that was thermal energy, so friction on the skateboard wheels leading some of the kinetic energy and potential energy to turn into heat. Sound could be another way, light. All those could be examples of lost energy. Or it's not that it doesn't go anywhere, it turns into heat, so it turns into a different type of energy. But our skater, once we turned on friction, was losing energy. The total kinetic and potential energy got lower and lower every time she went back and forth because more and more of it was being transferred into thermal energy. So in order for this skater to gain energy, she either needs an elevator of some sort to lift her up to the top, so add energy to the system, or she needs to do work in the vertical direction. Now, if she's overcoming the force in the vertical direction, that's the force of gravity. We know that equals her mass times acceleration due to gravity. The distance she moves is her height. So work is force over a distance, and then in the case of going vertical, the change in gravitational potential energy equals the work done in that direction. So here she is. She does work to get to the top of the ramp. You can see her total energy on the left there. Right now it's all potential energy because her speed is 0. She's not moving. As I release her, you can see that that pi starts to turn into kinetic energy. At the bottom, it's all kinetic energy. The size of the pi represents the total energy. You can also see that in our bar graph over here. That amount of total energy is remaining the same. The size of the pi is the same. Energy is not being created or destroyed. It's just being transferred back and forth between kinetic and potential energy. As she goes up the ramp, she slows down but becomes further and further away from Earth. And that leads to more potential energy. When you see her start to come down the ramp, she gains speed, and that becomes kinetic energy. If I added friction, then you can see that slowly friction's acting on that skateboard as it goes down, and the amount of thermal energy that results is going up steadily, which means each time she goes back up on another swing up the ramp, she's not going as high as before, and eventually all this energy would turn to thermal energy. Again, though, energy is just being transferred. So here, the total kinetic and potential energy is slowly going down because it's being transferred into thermal energy. So now is when I'd like you to pause the video, And take a look at our free response question. What do we mean when we say energy is conserved for the skateboarder from our lab? So you should mention transfers of energy, and the total energy should be included in your answer, which doesn't need to be more than 2 to 3 sentences, but must be in your own words, and should be based on our lab. So pause now and answer the free response. Work done is energy added to a system. So for example, me lifting up a marker, I'm doing work on that marker. If I'm lifting it straight up, I'm giving it gravitational potential energy, and the amount of gravitational potential energy it gets is equal to the amount of work I've done, or the force I've exerted in times the distance. So let's look at what the force is. In this case, we have a 3 kilogram box lifted from the ground to a 2 meter high shelf. We're looking at how much work is done. Well, it's force times distance. What's the force? Well, the force in the vertical direction is the force of gravity. The force of gravity, we abbreviate F sub g, and that equals mass times acceleration due to gravity. The distance is vertical, so it becomes the height that it's lifted to. And if we look at this formula, we see that, wow, that work ends up becoming the formula for gravitational potential energy, mgh, mass times acceleration due to gravity times height. So work done in the vertical direction is how much gravitational potential energy an object gains. In this case, we have 3 kilograms as the mass times 10 meters per second squared, acceleration due to gravity. So the force would be 30 newtons times 2 meters, the height that it was raised. So a total of 60 joules. That means that box now has 60 joules of gravitational potential energy. If that box were to drop, like the table were to slip out from under it, the instant before it hit the ground, all of that energy would be kinetic. And we would see that as in the form of motion or the velocity of the box right before it hits the ground. Once it hits the ground, that energy dissipates and becomes thermal energy. There's a sound. It all ends up becoming thermal. Okay, here's your multiple choice question. How did the skateboarder come to have the energy she did when she started going down the ramp? Which of these answer choices best represents how she came to do that? A, B, C, D, or E? Please pause now, answer the multiple choice, then talk about how you're going to use this in your topic challenge, the rocket topic challenge, water rocket, and any questions you may have. Make sure you submit your work, and you should receive an email that confirms that you've turned it in. Feel free to go back in the video if you want any help, as I talked about this a lot throughout the video.